Hello everyone. In this lesson, we are going to do the blink example provided by Arduino. In this lesson, you will learn how to program your Uno R3 controller board to blink the Arduino's built-in LED and how to download programs. Programs by basic steps. Yes. Okay, so I'll open up our camera, and this is the Allegoos Uno R3 board, and over here, this is the LED that I'm talking about, the built-in LED that we can control using our sketch. And here we have a compatible board, and although the layout is basically the same, but the format is a little different. This light right here is the this LED. Alright, so all Arduino Uno boards will have the LED somewhere in the top left quadrant of the board. Alright. So the principle. The Uno R3 board has a built-in LED, the one that I was just talking about, that can be controlled from our sketches. There's only one LED that we can control with our sketch. The other ones, although they are LEDs that can flash and everything, they cannot be controlled with our sketch. This LED is often referred to as the L LED, as this is how it is labeled on the board. Alright, so some additional knowledge. You may find that your Uno R3 boards LED already blinks when you connect it to a USB plug. This is because the boards are generally shipped with the blink sketch pre-installed. So in this lesson, we can reprogram the Uno R3 board with our own blink sketch and change the rate at which it blinks. So it can blink at 1 second, 2 seconds, half a second, or it can blink ununiformly, or all of that. Alright, so let's open our Arduino. So we can go to the examples by going to examples, 01.basics, and blink, which is this. And we don't need the code that I was writing before, so we can close this. Alright, so this is the blink. Let's say the path to it. We can find the blink example code in File, Examples, 01.basics, and then blink. Alright, so on the Arduino board, in the blink sketch, we can see that there's a lot of grayed out areas, all of this, and then there's the actual code that is in vibrant colors, some blue, some red, orangey colors, and so on. So this part, characterized by starting / or / and ending with a */. This section is a block comment. It is intended to be read by humans and not the machine or computer itself. And so when computers compile and run codes, they do not read any of the comments. So block comments is characterized by a start and an ending, and everything in between is whatever we want. On the contrary, there are single line comments which have a start, 2 forward slashes, and no end. It just means that whenever there is 2 slashes, it means a comment has started and the computer or the program no longer needs to read anything for this line after they see the 2 slashes. So everything afterwards is a comment, but before it, it is still code. Alright, let's read what this writes. Blink turns an LED on for 1 second, then off for 1 second repeatedly. Most Arduinos have an onboard LED you can control. On the Uno, Mega, and Zero, it is attached to digital pin 13. On MKR 1000, on pin 6. LED built-in is set to the correct LED pin independent of which board is used. If you want to know what pin the onboard LED is connected to on your Arduino model, check the technical specs of your board at https://www.arduino.cc English main products. And then they write who wrote it. The code was written on 2014 May 8th by Scott Fitzgerald and modified twice, once in 2016 September 2nd by Arturo Guadalupe, and again on September 8th, again in 2016 by Colby Newman. So this code, as of right now, has existed for 10 years already, because right now it's 2024. And the reason it was modified was because new boards were added, the Uno and Mega, and it needed to update the comments. The code itself probably didn't change much. Alright, and it says this example code is the public domain. So it's public knowledge, anyone can use it. Alright, now let's look at the code itself. So it is characterized by 2 blocks. There's the setup block and the loop block. The setup function runs once when you press reset or power the board. So it means that the setup function, anything starting from this curly bracket and ending to this curly bracket, is run once at the start of like the running, and inside there is a single line of code. And this code is the comment above. It says initialize digital pin LED built in as an output. So LED built in is what we were talking about here. LED built in. On Uno board, it is pin 13. So if we hover over it, it will say it was LED built in pin 13. And then this basically tells the board that they need to set up this pin for an output so it can power on the LED L and power it off when needed. So this is what the setup does. Next, in the loop, there's a comment saying the loop function runs over and over again forever. So what this means is that once it finishes setup and jumps to the loop, it loops through this once, twice, 3 times, and on and on and on until we either stop it or it runs out of power. So inside here, the first line is digital write, which means that we are controlling the output for the LED 13. I made another lesson on this. I think it will be a few lessons down the road in this course. And it's saying LED built in, so pin 13, and turn on the voltage level to high. So this means it is giving power now to the LED L, and we can now turn the LED on. And then the next line in the code is it delays for 1,000 milliseconds, which is a second. So the delay function is a parameter that is set in milliseconds. So 1,000 milliseconds is 1 second. And then after waiting for a second, the computer then reads the next line, which is again telling LED pin 13, built-in 13, that we are making the voltage level to low, which turns off the LED. So this is turning it on, waiting a second, and then we turn it off again. And then the last line in the loop is to delay it for another second, or 1000 milliseconds if you will, after which it sees the ending curly bracket for the loop function and loops back to the start and runs it on again. It turns the LED on, waits a second, turns it off, waits a second, loops again, turns it on, waits a second, turns it off, and waits for another second. Alright, so now that we understand the gist of the code, there's a setup and a loop section, we can now upload it onto our Uno board. So here, let's first use our compatible board, which is not in a case, and we need to plug this in like so. Alright, and then we can select the correct port. This is Arduino Uno on COM6, yes. And then we can make sure by going into the device manager, looking at the comms. Right now COM6 is here. If we unplug it, and let's wait some more. We just need to wait until it refreshes. Alright, now COM6 has disappeared, and that means that the compatible board is on COM6. Alright, now let's upload our code, which is what I was talking about. Let's upload this, compiling, uploading, and then it's done. Now let's look at our Uno board. Now it's turning on, waiting a second, turning off, waiting a second, turning on, waiting a second, turning off, and so on. So now this looks cool and all, but this is a little bland. Let's try and make it a little faster. So instead of waiting a second, let's wait half a second. So let's turn this into 500 milliseconds, and this should be twice as fast. Let's see. Alright, uploading. And now you can see that it's twice as fast. Let's try and go even faster. Let's do 0.1 seconds. So 100 milliseconds, like this. And then let's upload this. You can see the transfer and receiving light. And now it's lighting up really fast. Alright, and another thing is that these two numbers don't have to be the exact same. For example, if we want the light to stay on, flash off for a second, or like for 0.1 seconds, and then flash back on for a second, then we can do something like this. We turn it on, and while it stays on, it waits for 1 whole second, and then it turns off, and it stays off for 0.1 seconds, loops back, and it's on for 1 second again, and then turns off for 0.1 seconds. Now it will be, oh, did something happen? Oh, I changed the low, oh, sorry. Alright. Yeah, now it's staying on, turning off, staying on, like this. Now, yeah, so now the time it turns on and the time it turns off is not the same. Okay, now that this works on a compatible board, we can also try it out on our Elegoo Uno R3 board. So we can unplug this one, and then let's open our device manager. So over here, wait until it refreshes. So COM6 was our compatible board, and now let's connect our Elegoo R3 board, and see which COM this is in. Let's wait for it to refresh. And this is COM 7. Okay, so let's close the link for a sec. We can pick COM 7, Arduino Uno, make sure it's the right one. Alright, and now let's flip it. Let's make it turn on for 0.1 seconds, and then make it stay off for 1 second. So now it should flash on and then stay off. Flash on, stay off. Let's upload this. So now it's flashing, turning off, flashing, turning off, flashing, turning off, like so and so on. Alright, so now that you've learned how to manipulate some of the parameters for the delay and understood how to turn the LED on and off and pre-pin moding it and learning about comments, now let's head back into our notes and let's write down what we learned. So for the comments, everything between the / star and the * is what's called a block comment. It explains what the sketch is for. And it's good practice to have them at the start of some sketches if you are going to share them with others, or even if you might look back at your sketch sometime later on and you might not remember what the sketch was for. And the whole line, the other type of comment is a line comment. The whole line starting at 2 / is a line comment. It explains what a section of the sketch is for. So remember, it has to wait until it sees the 2 /. Everything in front of the / is still eligible code, and everything afterwards for the whole line is comments. So these are comments. And we also learned about the delay function. Delay is a forced pause in your sketch, or wait, if you will. The parameter included between the brackets is the amount of time paused in milliseconds. So in here, again, 1000 milliseconds is 1 second, and so 500 would be half a second, and so on. Alright, let's write that down actually. 1000 milliseconds is 1 second. Alright, that's it for lesson 3. And let's include some homework actually, before I forget. Homework, let's say, is to let's say take a picture of your Uno board while the LED is on. Alright, now that is it for lesson 3. Thank you for watching and see you next class.